Hey, welcome back to Math with Patrick and Quill. Today is December 19th, and we're solving problem 353 from the Daily Epsilon calendar. And the answer today should be 19 because that is today's date. So we have a sum. Looks like our lowest value here is negative 19. Our highest value is positive 18. And once we plug in these values in for t and add up all the terms, we should get 19. I just want to figure out what this sum looks like as we plug in the various values for t. So we would start with t equaling negative 19. So we'll have 1 over 1 plus 37 to the power of, and then negative 19 times 2, which is negative 38. And then plus the 1 gives us negative 37. So it's kind of cute that the 37 is showing up twice. Then the next number we would do is when t is negative 18, we'll have 1 plus 37 to the power of. And then here, instead of doing all that math, I just know that we're going to be 2 off from negative 37. So this is going to be negative 35. And this pattern should just keep continuing. So 1 over 1 plus 37 to the power of negative 33. This corresponds with t being negative 17, so on and so forth. I'm kind of curious what happens in the middle of the sum. Maybe we could think about when t is, say, negative 1, 0, and 1. When t is negative 1, we're going to have 1 over 1 plus 37 to the power of negative 2 plus 1, so negative 1. Then when t is 0, we're going to get same fraction, just different exponent, right? 37 to the power of 0 plus 1, so 1. And I'm actually not going to worry about the next one just because I want to kind of see what the middle part of this sum is. And I'm noticing that we have basically all the odd numbers from negative 37 all the way up here. This is kind of the middle part. And then finally, we're going to cap out when t is 18. 18 times 2 is 36, plus the 1 is 37. So we get 1 over 1 plus 37 to the power of 37. So we could try finding the individual value of everything. Maybe we could get rid of these negative exponents. A negative exponent is basically just like dividing. So we could stick anything that has a negative exponent into the denominator of a fraction. And that's what we could do for all of the kind of upper fractions. Maybe taking this first one here, this would be the same as 1 over 1 plus, and then 1 over 37 to the power of 37. This is kind of hard to read because of all the nested fractions, but this right here is going to be a very, very large number. So this fraction is going to be relatively close to 0. So overall, 1 divided by 1 plus essentially 0 is going to give us a number that's about 1. It is going to be less than 1 just because the denominator is slightly bigger than the numerator. But those fractions on that end of the sum are going to be really close to the number 1. On the other hand, on this side, 1 over and then 1 plus 37 to the 37, this again is a really large number. Adding 1 keeps it really large, and then 1 divided by a really large number is getting really, really close to 0. So what's kind of interesting here is in our sum, we have numbers that are close to the number 1, numbers that are close to 0, and then I guess somewhere in between here. And I would like to prove something here. I'd like to prove that all of our terms pair up and create the number 1. Like, maybe let's take a look at this pair first. I'd like to claim that both of these added up equals the number 1. And to do so, I'm going to just use a variable. Instead of 37, I will just use a. So let's do 1 plus a to the power of negative 1. And then we'll do plus 1 over 1 plus a. And it is, I guess, to the power of 1 here, but that doesn't really do much. And I'd like to show that this is just the number 1. Maybe for starters, let's rewrite our negative exponent here as 1 over a instead. And on the left side, let's try to find a common denominator in our denominator. This would be 1 over a plus 1 over a. We can safely assume that a is not 0, so this is a totally fine step. We could combine those denominators together, so we have 1 plus a on the top, and then we just had a on the bottom. And then whenever you have 1 over a fraction, you can just take the reciprocal of the bottom fraction. So far, this is still equal to the top. And then we have plus 1 over 1 plus a. Here the denominators are the same, so I can just add the numerators. And what do you know? This is just equal to 1, as long as a itself isn't 0 or -1. And looks like for all of my examples here, I'm never going to get a 0 here because 37 to some power never is 0. It's also never negative. So fortunately, I can do all those algebra steps that I did, and these two fractions together add up to the number 1. And this is going to be true for every other pair in this sum. Say I take the the 37 to the power of -37 term, and then the 37 to the power of +37, I could do that exact same process and show that both of these add up to the number 1. So in the sum, we have a whole bunch of 1s, and we're just pairing up all of our terms outside in. So we just need to count the amount of terms we have on the negative side or the positive side. We're just trying to figure out how many odd numbers we have between, say, -37 and -1, or we could do the same thing where it's between 1 and +37. And for this, I guess we could just maybe count back a little bit. So this would be the same as counting the numbers between 0 and 36. Given that we're counting by 2s, this would be, instead of counting all the even numbers between 0 and 36, this would be the same as counting all just the numbers between 0 and 18. And then whenever you're counting how many numbers you have inclusive between two numbers, you can just take the difference between the two, but add 1. Like, just to show, for example, if we want to count the numbers between, including 2 and 4, we can't just do 4 minus 2, because that just gives us 2. We have 3 numbers. So adding on the 1 does count all the numbers appropriately. So that's why I know that I need to add this 1 right here, and I do get 19. So that does show that we get 19 odd numbers between -37 and -1, or 19 odd numbers between 1 and 37, or 19 pairs of fractions that add up to 1 each. So that's how I know that the answer today is 19. Great, so I think we're all done. Thank you for watching, and I'll see you tomorrow. Bye.